In this video on the nuclear model, we're going to talk about the atomic structure. So you should be at this stage familiar with the concept of your protons, your neutrons and electrons, and I'm just going to recap that very quickly and just explain what we mean about the two different types of forces that apply in the nuclear model. So if we have a basic proton neutron combination, hopefully you can identify that if we've got two protons, that means that it is the second element in the periodic table, so it's helium, has the same number of neutrons, and then on the outside it's going to have these negatively charged electrons. So this is the configuration of the atom. The electrons are negatively charged, protons are positively charged, neutrons are neutral charge. One of the important things to know in terms of forces is there's two types of forces. There's what we call the strong force, and then there's the weak force. So the weak force is the more commonly known one, which is all about the electromagnetic attraction or repulsion between things. So that tells you that if you have a positive charge and a positive charge, they repel, they're pushed away. And if you have a positive and negative charge, that they're attracted to each other. So that is what we call the weak force, that electromagnetic attraction or repulsion between charges. When we look at the strong force, however, the strong force is actually what happens within the nucleus. So we call these things nucleons. Everything inside the nucleus, your protons and your neutrons, make up nucleons. That's just the collective term for it. So the thing that actually holds these together is the strong force. And this might seem a little bit weird at first because you've got two protons which are positively charged, which don't want to be anywhere near each other, and you've got two neutrons which are neutrally charged, and they couldn't care less. So why the heck do these things even stay together? Shouldn't they all just blow apart? And the reason that they don't is because of this strong nuclear force. So that's the important part. What the strong nuclear force is exactly is a little bit more complex, and we don't cover it as part of this course. But as long as you know that the strong nuclear force is basically like the glue that holds the nucleons together. It keeps those protons and neutrons stuck together, and it's much, much more powerful than the weak force, hence the name, that is that electromagnetic attraction or repulsion between charged particles.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.